once again, a little poll. Couple questions. What did you think about the class and its kind of its new iteration? And how much SQL do you think you've learned in this experience? So if you don't mind, please participate while I'm taking attendance. And we'll start in a couple minutes. Hope everyone had a joyous Easter. Hope you were able to get some rest, eat a lot of food. That's what I did. I rested and ate a lot of food. I didn't even help cooking. Oops. I was pretty lazy. Well, I wasn't that lazy. I actually did some yard work because it was nice and cool outside. But there, so I deserve the big meal. Okay. So please participate in the poll. I posted a poll. I'm going to close it here in another minute. A couple questions, 2 questions. First is about the class. I kind of restructured some of the curriculum to make it a little more appropriate for our current times as far as databases. But all right. So another minute, and then we'll get started. Turn my AI on. All right. I'm going to go ahead and end the poll. And maybe 1 more minute. A couple people that may show up. And we're getting late. All right, I'm going to go ahead and end the poll and share the results. Can you all see the results of the poll? So most everyone liked the class, 80%. Thank you. It was fine, so no negative responses. As far as SQL, as long as you're adequate, then you have a fundamental knowledge of the query language. I would practice. If you're going on in other classes, you'll see it again. No one stated they didn't learn anything, so everyone learned something, and that's all. That's what we always shoot for. So being proficient, I know that's subjective. Even I don't think I'm proficient all the time, and I've been using SQL for what, 50 years now. And so, all right, let's stop the poll. And let me share my screen. Yes, we're coming to the end. We technically only have, well, this is our last official lecture or lecture curriculum material. I'll talk about what's entailed for the last 2 weeks. We will meet next week, the 28th, and we will meet on the 5th. The 5th is essentially our party week. We'll have a virtual party. Yay! We'll share virtual pizza and water and soda. It'll be great, right? Oh, well, that's something to look forward to. All right. But I'll talk about what's happening for the last part of the class. It's been my pleasure to guide you all through SQL. And make sure I share my screen correctly this time. Start out. I've only been using this Zoom tool for how many years? All right. Okay, can you all see my PowerPoint slide and not the presentation mode, right? Thanks, Vera. All right, April 21st. Just to repeat myself, our class ends officially on the 9th of May. I'll actually be in California during that time, so don't bug me. No, you can bug me, but that's our official end date. That's when the finals due. That's when the final project is due, and I'll talk about that at the end of this lecture. Let's just get right into it. Technically our last two learning modules of the course, module 17 and 18. This particular material, you won't see a lot of it on the SQL side, but it's good knowledge to understand. You probably won't have to deal with privileges, but you need to know how that works. And regular expressions, that's always interesting to learn. In the old days, we use regular expressions all the time. It's kind of a shortcut, and you'll see that. And then transaction control language, this kind of leads into, if you go on to do the programming part of SQL, you'll see the TCL language used a bit more. So this will be kind of an introduction, kind of a whiz through there. All right. So we're going to start out right out with the subject of controller user access or privileges. Basically, we're going to look at the difference between object privileges and system privileges. Move my little. Oh, that's fine. Two commands required to enable users to access. Okay, just to set the stage here. Basically, you can't change any of your privileges on these schemas that you're working with. So generally, you'll get errors. That's fine. So this is the one time I will allow you not to show your work in the developer, because you'll basically won't be able to satisfy some of the requirements. So please don't worry about it. Just write the appropriate queries and commands, and you'll be fine. So it's going to be an easy week. Yay. Construct an execute grant, all of the grant and all that, you won't be able to actually run. Unless you go in and hack, you can go in and hack the Oracle server system. I will allow you to do that, although I wouldn't suggest it, but, and then query the data dictionary to confirm privileges. Once again, you'll be able to view privileges. You can't really change them on these schemas. But here's the premise around it. Basically, if you're in a real database environment, essentially outside of the school, our little school scenario here, it is nice to understand how privileges are controlled, and that's the gist of this lesson. In the purpose, it talks about the school and home, and well, if you're adventurous enough and you want to set up a database, I don't know why you would do that unless you have a home business or whatever. You will need to, because most of these developer or enterprise platforms are free. Just to let you know, although we don't go into the details of creating a database, but you have the requisite knowledge to research that and kind of figure those things out if you're wanting to. So that's right. So the purpose is essentially control the access and privileges. This is the security side. So it is important to learn this. So in a multiple user environment, I will tell you though, and I'll probably change this lesson a little bit, because, and this is kind of a tangent, but bear with me. In the cloud database environment, which you are actually exposed to now, you can set up instances where users only have specific access to certain parts of the database. So privileges are shifting a little bit, but we're going to learn the old way that DBAs use to control database access, give us access to specific objects, confirm given and receive privileges, and create synonyms, which you know what synonyms are. We actually went over that already. That's kind of a repeat. But that is a part of the privileges, views, creating views and all that. So there's several ways to control privileges. but we're going to learn the database administrator way to understand security on your database. So there's two categories that can be classified as far as security, system security, and data security. And you probably figure out which is which. So system security covers access, use of the database, system level, users, usernames, passwords, disk for users, everything that the database administrators have fun setting up. Yeah, I won't go into that too much. And then data security, also known as object security. And remember, within your database, you have objects, whether it's tables or any of these other particular objects, views, and you're going to learn different types of objects if you go into the PL SQL, which is kind of the programming language of SQL. But so these privileges include being able to execute. So you can execute any of the different types of SQL. Those are all controlled by privileges. And once again, with our little cloud, the way that we're set up in the Oracle instance now, as a user, as a matter of fact, our administrator goes into these instances and ensures that each of the users, those student accounts, you have all the levels of privileges that you're going to learn about in this lesson. So privileges are the right to execute particular SQL statements, and you can draw it down now under the Oracle umbrella to the specific commands and not just users, but so you'll see the difference here. I know I'm rambling, but yeah, it'll make some sense. This is kind of a lecture heavy topic, so bear with me. So as a user, you're required certain privileges. Generally, in all realism, you never have the types of privileges that you all have now in your database. If your database was as wide open as we're dealing with now, you would run into problems as a database administrator. And the good thing about DBA is they can monitor, who's doing what and adjust privileges accordingly. So as you know, a schema is a collection of objects. That's the whole idea of the database. Tables, views, as I said before. A schema is owned by the database user. So basically, within our little database, and ours is very simple. We don't have a complex schema. Oracle has always had this whole idea of complex naming conventions. But if we were in your student system for Chandler Gilbert, if you actually had access to the database, you would see more of what we're referencing here as far as privileges. So security is important, and it's one of the things that I do on the side. I'm kind of a cybersecurity nut. I've been for a long time, and especially securing data. You'll find that in many scenarios, you'll be tasked, even as a database administrator, to understand the concept of securing data. So in Oracle, there are 100 distinct system privileges. We're not going to cover all of them, obviously, but I'm going to try and help you understand conceptually the idea of what you can do as far as privileges. So some of the system privileges, as you can read on this little table here: create user, drop any table, backup any table, select any table, etc. Tables are very important objects in your schema, so you have to be very careful as to who can run those DDL statements. So yes, you can set the privileges of particular objects in your schema. All right, so getting on to some of the practical commands, and I'll reiterate, many of these you won't be able to run successfully because your system is locked into. Let me check our rule here just to make sure. That's my pause. Let's see. All right, give me a second while I'm reading from the wall of names. All right, and that reminds me, if I ever forget to mark you here as far as attendance, you can send me a message. But I can easily go back and check to see, on the recording. But sometimes I'll read names, I don't really see them. Yeah, that's okay. Let me get back to where is my no. All right. Okay, so as a database administrator, basically, and we obviously we don't do that now in our scenario, but you will go in at the very beginning and set up users. Of course, we your account to this cloud instance is that student whatever the number was, and yes, I just went and just assigned you based on I think it was last name. So, but you would go in and run a create user command, and with the password. So you see here the example here. Creating user Scott with that password, UR35 Scott. Very bad password, but oh well. And so I did want to point out, yes, you can set up these commands, but when you run them, you will not have privileges to actually run them. So please remember that. And I'm not going to ask you to take screenshots like I'm showing you here, but just to set up the query. Okay? Just remember that. All these privileges you will not be able to run because you don't have the privileges to set up privileges. Kind of defeats the whole purpose. But that's all right. I need for you to understand how to set them up, create them, and then alter them, etc. So they're just like any other types of commands. So during the assignment, just basically set the queries, and you don't need to show it in developer unless you're smart enough to go and hack your own privileges, although you can't do that on these instances. I tried. It's set up, it's a learning environment. So once again, there's a whole series of commands that you can launch, that you can run, setting up users and then actually granting privileges to certain objects. Here we're granting, using the grant statement to allocate system privileges to a specific user. So like we created that user Scott, right? So we'll grant create session, create table, create sequence, create view. We're giving Scott all of these privileges, okay? Does that make sense? It's pretty straightforward. Yeah, Oracle is pretty easy. And here are the 5 main ones as far as objects that you should know: create session, table, sequence, view, and procedure. Now procedure is something different, so you'll learn that in PL SQL. It's a TC, yeah. It's just something that's a little bit beyond the basic, but don't worry about that 5th one. So the level of this level of security covers access and use of the database. So as a DBA, if you happen to become a database administrator, yes, it's really that straightforward. As far as Oracle, creating users and then granting privileges. So here's some table level privileges that you can grant to a user. So alter, delete. Yes, you can differentiate to this level. And remember, you have to worry about procedure. That's a kind of a high level. But table, view, sequence, yeah. So yes, it is that granular. All right, so it is important to follow these 4 points regarding privileges. So the only privilege that applies to a sequence are select and alter. Remember, sequences use alter to change. Yeah, just remember that. To start with cannot be changed using alter. So all of those rules that you learned before, basically you're granting the privileges to make those, or to run those commands. You can grant update references, insert privileges on individual columns in a table. Now imagine that you can detail it or make it granular to where you're granting certain privileges to certain parts even of a table. I mean, that's how crazy it can get. So when someone's attempting to run a query that they do not have privileges to, yes, they'll get an error message like the one that you saw in the previous slide. You do not have enough privileges. And I'm pretty sure we've all run into that before. because some of the commands are already locked down, and it's not. Remember, we have constraints that will prevent us from, making changes that we're not allowed to. But privileges it means that you don't have that level of privilege. So as far as synonyms, remember that those are just, names that you're more human readable names or whatever that you can use for an object to make it simpler to identify. And we did learn about that before. And here's another part of privileges, using the public keyword. And remember, I don't know, we used this before, public and private. Usually public is associated with everyone, all users, and private is associated with a specific group. So you just have to remember that. That's the association there. And under the Oracle umbrella, I mean, as long as you set the privileges to public, although in our scenario, most everything is public to your instance. But if you had multiple users in one instance, then you can differentiate between public and private. And that's what I explained here. If you use public dot user, and remember you can use the level and then the object. So that user objects table, we're granting, making it public for anyone within the Scott. I guess we'll call it the Scott scenario. If Scott doesn't own that table, he can still access the user objects, et cetera, et cetera. So this is very. I wish we could run this in the class. An instance of the class before, we could actually grant and deny privileges, and you could see. But you'll have to conceptualize this whole idea for the most part. Confirming privileges, yes, there is a object. There's obviously in the data dictionary, but for our instance, and you will be able to run that as far as confirming privileges. So if you want to attempt to perform an unauthorized operation, such as deleting a row, et cetera, if you ever receive that do not have sufficient privileges, you can always check to see what your privileges are. And I know that basically you as a user will be able to do everything except change your privileges. That's generally where you will run into that error message. Let's see what else. So you can access the data dictionary, and remember, we're not using I need to change that, the Application Express developer anymore. We're using the true Oracle developer, so you do have a lot more access and power, meaning you can access all the objects in that data dictionary. So here are some of the privileges that you can view: system privileges, table privileges, row privileges, user table privileges made, and etc. What I would suggest, you can do a kind of a find or show tables in the data dictionary, and then just use the PRVS, and it'll show you all the privileges, all the tables that you can view the privileges. Well, if you have access, I haven't tried that particular part of it yet, but yeah, I may try that later in this lesson. But that's essentially user access, user creation, and privileges. And these are some of the key terms in this topic. Session privilege. Session is just, you open your session, and basically you can control who has privileges in that session. You all see when you log on to the Oracle developer, it actually launches a session. And then privileges, object security is that broader context of security. Privilege, public privilege, private privilege. I'm trying to say that fast a few times. Role. I glossed over role, and a role is just something you assign, like an administrator, like a user, like a super user, things like that. And you can assign different privileges to that role as well. And then schema is the overarching idea of the database. And then essentially that's our quick and dirty, down and dirty lesson on security, just high level. And I abbreviated this particular section quite a bit because of what we can't do is what we can't change. So I would much rather have it be more hands-on, and I will probably alter that some. Anyway, any questions about just setting up privileges? Pretty straightforward. All right, we're going to move on to creating and revoking object. Now, that is the high-level system privileges. We're going to detail object privileges. So this is primarily those objects and tables are probably the biggest things, the biggest item, the biggest object that we're going to address. So our objective is explain what a role is, because this is where I'm going to dissect roles, what its advantages are. Well, I'll tell you right now, roles are pretty important. And construct a statement to create a role and grant privileges to it. You probably figure out, if someone has this particular role, those privileges will go with it automatically. Construct a grant on to with grant option. This is just a way to put together essentially how you configure those privileges for your users. Construct and execute statements to revoke object privileges. Distinguish between privileges and roles, and that's something that you'll see on one of the tests. We're not really going to go into database links, but it is introduced in Oracle Academy, so I'll mention it a little bit. All right. So once again, here's that whole idea of sharing your database environment or sharing a computer. This is essentially the same lead-in as it was before in the last topic. But what I want to get to here, a role within this whole idea of privileges is a named group, like administrators or users or super users that can be granted to a user. So, and this method makes it easier to revoke and maintain privileges because you put all the users in a role. I don't know if you've all done any type of system administration. This comes from that whole idea. So you're not dealing with specific, because there's so many little privileges that you can change and alter, and it becomes a headache. So you assign roles and you're done. So a user can have access to several roles, and several users can be assigned the same role. So think about that. If you have a bunch of users and you have one administrator, that's the whole idea. And yes, and a role is typically created for a database application. And right now, that's a big thing because everything, mostly, that all websites and most platforms now are having to deal with some type of connection to data. So it is a big thing. So it's something you should understand, and it's a part of our world. Our tech world. I was a part of a world where databases were up and coming. Everything was dynamic. There's nothing, no real storage of data. So we had nowhere to put data. I mean, our computers were so small. Anyway, I don't want to go on too much of a tangent. But now we have huge resources, and we can store tremendous amounts of data. So we really do need to understand how to secure or how to ensure that the individuals that have access to that data are the right individuals. All right, and this falls under the guidance or the guidance of the database administrator, or DBA. I remember about 95% of my job initially, and ongoing, if there was a new scheme or a new whatever was dealing with users and privileges, would take forever. For example, I worked for a university, and every year, of course, you would have thousands of students coming in. Guess who's creating those, the privileges for those users? It was some of it was automated, but a lot of it was manual. Probably a lot of it's automated now. But when you're assigned a user ID, that will come with roles. And anyway, so that's kind of a real life example that I had to go through as a DBA. So I'm going to create a role as a manager. And these are some of the syntax: grant created table, create view to manager. So you've seen all the create. So remember, role is just a group, a broader group of users. So you create a role and then you grant that role to a specific user. So you see that scenario. And in a business, yes, you have managers, you have technicians, you have accountants, and that's in a regular company, you have those types of roles, which means that you give them certain privileges and basically certain access to certain tables, to certain other objects. It makes it easy, but it can be cumbersome as far as dealing with that manually. So here's the syntax for creating a role. Pretty straightforward. Create role and then give the role a name. So then after the role is created, the DBA can grant, certain privileges to that role. And remember, privileges, you'd have to go and see that list of objects, create table, create view, to manager, and the syntax is that. This is just a repeat of what I just showed you. So this example is pretty, it makes sense. You're going to name that, remember, manager is the name of the role, and it's the name of the title of that particular individual. And then you differentiate what this particular individual or individuals have access to. All right, some characteristics of roles, and this is still so rudimentary, but it's still appropriate. Roles are named groups of related privileges. They can, or usually they are granted to users, not monsters or AI. They simplify the process of granting and revoking privileges. And usually this is the DBA. And this is kind of a pictorial example. You have users and certain groups of users. Some are managers, some are technicians or whatever. So we have users with the role, users without a role. So it just gives you a pictorial representation of how easy it is to manage, to enable or to grant or revoke privileges based on a role. All right, so here's another kind of an extraction of a syntactical view of granting object privileges. So grant object priv, that's the name on whatever the object name is. This is just a general syntax. To user or role or public. Remember, you can use public, which means that you're granting privileges to everyone. And then I'll explain with grant option. So when you add with grant option, you're giving that user the capability of granting their own privileges. So here are the definitions. Object is just object privilege you're granting. It's a list, it can be a specified column list from a table, believe it or not, yes. You can differentiate it that way. Or you can do on object name, which is essentially the object you're granting the privileges to the user role or public. Remember, public is just granting it to everyone. With grant option just says that you're allowing whatever that privilege is or that group of individuals the privilege to grant privilege, so it's just a tongue twister, themselves and change their roles, et cetera, et cetera. You generally don't want to do that. It's one of those openings that Oracle provides that it's probably not a good thing as far as security. All right. All right, so to grant privileges on an object, the object must be in your, and with grant option just means that you're providing that option for users to grant their own privileges. All right. Okay, so here's an example. We know that Scott King is a top man in our little database. So he created the clients table. In example 1 on the right, all users are granted permission to select from Scott's client table. Example 2 grants update privileges to Jennifer. And she can only update first name and last name, right? Okay. If Jennifer now wants to select data from Scott's table, the syntax she must use is listed in example 3. So this is just basically saying that once we've set those privileges, then basically we can run the specific queries associated with that privileges that's set for the specific user. All right. What am I doing here? See the syntax in examples 4 and 5. Create synonym clients for Scott King. Got clients. Select star from clients. And what I'm doing here is once again creating. That's just creating a synonym. That's really nothing. But we're selecting a Scott King client as a role with certain privileges to that particular synonym, whatever that's a synonym. The synonym is for Scott King.client. So if you are going through the scenario, basically you're setting privileges for that synonym to whomever has privileges to Scott within Scott King's environment. Although we did grant select on clients to public, so we basically stated that particular object does have public privileges, so anyone can access. All right. So once again, a privilege that's granted using the with grant option, you're basically passing on to other users the roles by grantees. So which means that they can grant their own, they can change and alter their own roles and privileges. Yeah, it's a little bit confusing with the language from the Oracle Academy, but that's all the with grant option does. Gives you the opportunity to grant privileges that have been. Someone is granting you the privilege to grant privileges to yourself or others. Not good. And so that's what that does. I won't beleaguer that point. And public is another, I talked about this before. Public just opens up the privileges to anyone. And just opens up the object to anyone that can log into that, or that's a user in that schema. And you use the keyword public. Okay. So we know how to delete objects. It's usually a drop or delete, but you do have to have the delete or drop object privileges. Once again, you do have that in your scenario. The only time that and especially in our scenario, the only time that you're not able to drop an object or delete an object if it doesn't exist. That's the key here. So, all right. So you can revoke object privileges when you use the revoke statement, and basically you're denying. Especially if you did a with grant option by mistake, you can revoke that and essentially pull the privileges away from that particular user. And yes, it's the keyword revoke. And here's the syntax. So you can revoke certain privileges as they're listed, or you can revoke all to a particular user, to a particular object, or you can revoke public as far as the indication of the privileges to that object from any user. Right. The key phrase cascade constraints, basically you remove the referential integrity, all the objects that are associated with that particular object. So it's the same thing as cascading on delete. Basically, if you revoke objects at a certain level, then it will cascade down to any referential integrity object or any connection, like the departments and employees table, and basically like that. You can essentially revoke that without revoking the privileges on each of those objects for that particular user. That's what that does. I guess I needed to extrapolate the with grant option a little bit. So in this case that I'm indicating here, we're revoking select and insert privileges on clients from Scott King. So we're basically taking his privileges off, even if it had with grant option. So essentially, whenever you revoke something like this, the with grant option goes away. as a database administrator. It's just another way of pulling those privileges back so that you're probably managing them a little bit better. And if you are the database administrator and you're running a revoke or you've set something to public, yeah, it becomes a pain. I can tell you this right now. Whenever you're trying to control who has access to what, especially with these large databases, I will tell you from experience, you want to do this upfront just once and leave it alone. I mean, just either create those roles with certain privileges, and you go back and start changing things and everything gets confused. So, and there's some pictorial examples coming from Oracle when things like with grant option, and that's another reason why you probably don't want to use it with grant option, because you're opening the door as far as managing those privileges. But I do need to point that out. With grant option has pretty substantial power, and you're just opening the door for other users to control access, which that's kind of a security no-no. That's why I rarely use with grant option, but if you're needing to set that up so that you're controlling the privileges in a certain way, then that's when you want to use that. And that's why it's illustrated a lot in this particular lesson. I did talk about private and public. The main association here is that public is all users, private, revert, access to a specific group. It could be a role, it could be a privilege, but you control that access with the private keyword, whereas public is just like it says. I mean, you're opening it up to everyone. All right, so what's the difference between roles and privileges? You probably can look this up right away. Roles are specific titles. I'm summarizing this slide that are associated with privileges. So roles are the title. Privileges are the way that you access certain objects. And usually the way you can think of this, a role is like a manager or administrator, but they have certain privileges that will go with that role. And that's normally set up by the database administrator. So there's no confusion about who has access to what. So just remember that. All right, so database links, we're not going to use this, but I do need to point it out. It's defined as kind of a one-way communication to another database. The database administrator, and this used to happen quite a bit, not so much anymore because of the cloud. If they allow you access, so basically they will open up a portal, it's called a link or a pointer, and now you have access to another schema without actually technically, leaving your infrastructure. And so the database administrator, let's say a sister company or whatever, and we used to do this all the time. We would have to create a user and call it a link user. And basically you would log in with that link user. And now you have access to the data on both databases. So that's what a database link is. And that's kind of a pictorial representation. Oracle they call it a one-way, and it truly is. Although with the current technologies, I mean, you can bypass a lot of this, but in the old days, it was essentially a one-way. I'm allowing you to come and, access my data. And it was usually when there was a conglomerate or an enterprise, essentially purchase a sub corporation, et cetera, they would create these links because you're talking about a lot of data as opposed to rebuilding or copying the database. They would just link it from one schema to the next. So that's what a database link is. Like I said, I'm going to buzz through that because it's becoming older technology. This particular association. One of the primary reasons is because we have cloud technologies now where you just need to provide a role, call it a larger level, higher level company across a global enterprise because everything's global now. So you really don't need to set up these database links. And in the old days, you needed that because it was based on resources and internet speed and all these other factors, which you don't need to worry about. Yes, it's used as a DBA that sets that up. And this is kind of a high-level example using a synonym to set up this particular object so that the user at the one company, et cetera, et cetera. So you can go back and review these, but database links are rarely used. I'll just tell you that's why we're buzzing through them now, because of the ability to share environments, et cetera, without creating like you can kind of think of this as like a pipe between two corporations. We don't do that much anymore. I'll just state that. All right, buzzing through this topic, create roles, know the difference between a role and a privilege, revoke roles, revoke statement, public and private, and synonyms, and database links. Okay. All right, regular expressions. This is kind of a fun topic, only because, I mean, it's something good to know. We have other scripted scenarios where you probably won't run across regular expressions much anyway anymore, but it's a good topic to learn. So we're going to describe what a regular expression is, use regular expression to search, match, replace strings in a SQL statement. And that's, I guess, to try and explain this, when SQL started, it was its own little scripting environment, but in some of the earlier low-level languages, especially on the programming side, there was not a match between, if you were building something outside of SQL. So this is how regular expressions. And regular expressions, I don't know if you know anything about math and statistics, it comes from that environment, but it was incorporated in scripting. So I know you're probably like, oh, what is he talking about? Well, just bear with me. It'll make some sense. So we're going to look at regular expressions. So sometimes you have to find and replace particular pieces of text in your string. Specifically, I'll say that maybe you look at a particular application and you can't build a SQL query like a select query exactly. So you have to kind of use like wildcards or something to put together your query in. Well, before the higher level programming languages, in the old days with C and BASIC, and it was always regular expressions to build a query. So it's all about putting text together to make sure it is read by a database engine like Oracle or SQL Server, so it actually recognizes it as a query. So it's basically a method of describing both simple and complex patterns for searching. I mean, you'll see. They're used widely in computing industry, and because of although I'll tell you now, the advent of Python and some of the higher level object-oriented languages, they really don't need regular expression. But back in the old days with Unix and some of the old D-based systems, yes, it was always, if you don't put a regular expression into play, then you probably will not be able to build a query. So what are regular expressions? It's based on the use of metadata. If you know, it's data that describes data. And these are characters and special, or meta characters are special, or meta characters, I should say. They're special characters that have a special meaning, such as a wildcard character or repeating character, a no matching character, or a range of characters. So you can use several predefined meta characters in the idea of symbol, in the idea of pattern matching or symbols in the pattern matching. So in the next slide, I'm going to show you what I mean. So if you have the dot, which is your little period, as far as a meta character, that matches any character in the supported character set except null. Question mark matches 0 or 1 occurrence. So these are just meta characters. They're not There identified that in your regular expression, and you'll see what I mean here when I get to actually putting together a regular expression. So star matches 0 or more occurrences, plus matches 1 or more occurrences of whatever you're looking for. Parentheses, grouping expressions treated as single sub-expressions. A backward slash escape character. An escape character, that's right out of programming land. A pipe or the straight line. Alternation operator for specifying alternative matches. And you'll see what we call the caret / matches the start of line, end of line. These are right of the programming parallels. The square brackets for matching a list. All right, and you're like, well, what does that mean? Okay, so a simple regular expression is very similar to the wildcard searches you're already familiar with, like the star. Let's take a look at an example. So let's use the dot operator to look for a better letter A, or look for the letter A in a text, followed by any one character followed by the letter C. So we're looking for the letter A, followed by any one character, followed by the letter C. As a regular expression, this would be done as, and within the single quotes, A.C, right? And so that's the same expression as a standard SQL wildcard search. Remember the underline was a single character. Remember that, like A underline C. So it's the same thing as that, but that's the regular expression. All right. So with that in mind, so which of the following strings would match? So these are just strings, there's 8 of them. Which would match this regular expression A.C? A, single character, C. Which one of these match? Anyone going to answer that? Is it 1, 2, 3, 4, 5, 6, 7, 8? Which one? We're not sure. A, one letter, C. So it's definitely 2. Case does matter. Not 3. It's definitely 4. Is it 5? Definitely 5. Is it 6? No. Is it 7? No. Is it 8? No. So it's kind of a way to search, and that's so that's 2, 4, and 5. That would be correct. Now that's essentially the whole idea of, you're probably thinking, when would you use that? Well, so Oracle provides a set of functions that you can use to search and manipulate strings. So this is the whole idea of searching for strings and manipulating strings. And if you needed to do, move into that functionality to manipulate your data. And I'll context it by saying that, you have entry forms and things like that where someone may not know how to spell a particular word and you need to change it. You may need to use a regular expression to search and manipulate that data. And that's one of its usages. All right. So there are some regular expression functions. Here's 5 of them. Like, similar to the like operator, performs regular expressions, matching instead of simple pattern matching. Regex replace searches for a regular expression pattern and replaces it with a replacement string. Regex inst searches for a given string for a regular expression pattern and returns the position where the match is found. Regex, that's in string, and this is substring, just like those functions we've been exposed to before. Searches for a regular expression pattern within a given string and return the matched substring. And then regex count returns the number of times a pattern appears in a string. You specify the string and the pattern. You can also specify the start position and matching position. For example, C for case sensitivity. Yes, and remember, these are just functions. So here's a good example of when you would possibly use a regular expression. So assume we were to ask to list all employees with the first name of Stephen or Stephen with the PH or the V. You would write a regular expression, so like first name, last name from employees, where regex, like, just like before, first name. And you see, we put this together, start with an uppercase S, T, E, and then within the parentheses, we have V or, the pipe is kind of like an or, PH, ending with EN, and the dollar sign says it ends with that. And we would, and you can run this query and it should return Stephen King. So we're saying specify the start of the string. That's a little caret top, or whatever you want to call it. That's above the 6 on your keyboard. And then we specified uppercase S, followed by a T, followed by an E, and then V or PH. The pipe is an or, lowercase p, lowercase h, and that's our group. And then lowercase c, lowercase n, and then the dollar sign specifies the end of the string. So that's why we got that result. And you can see where you can use that if you don't know, if a particular item, you can put together. Now there's other ways to search for this. I mean, you could probably use a like command, but you wouldn't be able to group it this way. You probably have to run more than one query. That's one of the usefulness of it. So we want to replace, and then the regular expression replace function will replace one string pattern with another. So in this example, we're going to look for an uppercase H followed by any vowel, A, E, I, O, U, right? And replace them. So you want to build like a representation of a password or something. So we write our function is regex replace. We're going to look for start of the string, uppercase H, and then the group of vowels, right? Right. And we're going to replace any association of those with a double star. So you see here, Abel, no, oops, Davies, no, Dahan, no, Ernst, no, Faye, no, and we're using last name. But we get down to Harstein, yes, H-A, double star, right? Hernandez, H-E, double star, Higgins, H-I, double star, etc. And I've used this before to mask. It's kind of an easy way to do some cryptography. And that's a way to use that particular function if needed. Now you're probably asking, how do you reverse that? Well, hopefully you're only using this to display, you're not updating the information in the database, right? Which you never want to do that. So yes, this will replace, because we're using a select command here, right? We're not changing these last names at all. We're just displaying them this way. Remember that. All right. We can use the regular expression count, which returns the number of times a pattern appears in a string. And so don't ask me why you would do this, but who knows? We want to select the number of times AB appears in these country names. So we use the regex count, country name, and our little pattern here is AB. And basically where that count is greater than 0. So all of these returns have one instance of the AB. And I think, yeah, see, Arab. Maybe you're looking for Arab or Arabia or whatever. And you see here, that may be useful somewhat, but you can see how the regular expression can help you find particular texts. So regular expressions could also be used as a part of an application code to ensure, yeah, you have only valid data that's stored in a database. I know that I use a regular expression always for emails because you need to have that @ sign, right? That sign and a .com or dot. There's so many domains now. I remember where there was only 3, believe it or not, as far as email. Now we have thousands. Edu, com, org. We weren't allowed to do gov, but 4. So it's possible to call to a regular expression function, for instance, a check constraint. So, and this is one that I've run many times. So, and basically we're creating a constraint using regular expression to ensure that there's an @ sign in our email. And that's how you would write this. So if a user tried to enter or update that column with something without an @ sign, it would reject that. You would violate the constraint. And that's an easy one. It's just a check constraint with a regular, and you can't really do that any other way. All right. Does that make sense? Yeah. Very useful one. I've used that one many times. And whenever I build a table that has email, it always has this constraint in it. So, all right. So you can even expand that. And I've done this before to make sure it's following its particular format. So I even use this particular constraint to make sure it follows. Now, as I said, with the domains now, it's, you have so many different ones now, but you have an @ sign, you have something before the @ sign, something after the @ sign, and it looks like an email. So we're just using a check constraint, which is, I think you'll get to do this in one of the exercises, just to make sure you're not violating that constraint by adding an email. And in our email, in our employees database, we don't even have an @ sign. So we just, maybe I'll have, in the future, I'll have you all change that to an actual email address. Something like that. So as far as describing what's in this constraint, means one or more characters, that + here before the @ sign, and then the \dot. This is an escape character. Basically, it's checking to make sure you have something that looks like an email, @ and then whatever. That's generalized a lot. You can just, but you can clarify that constraint to be specific. If you're at a college or university, I mean, you can specify it to be edu. If it doesn't end in edu, then you don't satisfy the constraint. Things like that. So meta characters, regular expression. This is probably the easiest way to describe this, is that you can set conditions, and as far as database administration, setting those check constraints so they're specific to the data that you need to have written into those tables. That's probably its best use as far as regular expressions. But once again, this is one that I kind of abbreviated a little bit, but there's a big library, and I think I go over that resources that talks to regular expression and their usefulness. All right, we'll take a quick break, stretch, take a deep breath, get a drink of water. We have one final little section to talk about, and that's TCL, database transaction language, which if you go into the PL SQL, oh, someone's writing in the chat. Oh, okay. Thank you. All right, quick check of attendance before I go into my last little. Oops. All right. We're looking. Okay. Okay, let me go on to our last little topic. Let me see myself. All right, here we go. Module 18, or kind of my last major high-level topic. We're going to talk about database transactions. And transactions are basically a way that you can put multiple queries together and run them in sequence. And like I said, you'll learn more about that as you go on to PL SQL, which is the next class in the sequence of SQL classes that you learn. And if you're going through the certification, we're going to find the term commit, rollback, and save point. We saw this before. We're going to actually look at that because that's a part of the transaction. There's three advantages of commit, and you can probably think of them just like programming. I explain why it's essential from a business perspective to control the flow of transaction processes. Yay. Oops. All right, so here you're at the bank. So what if a bank had no systematic process for recording deposits and withdrawals? You're haphazardly throwing money away, and you probably don't want to do that. So how would you know if a deposit was credited to your account before you needed to withdraw money? So that could be very confusing. So fortunately, banks control transaction processes to ensure data consistency. The banking systems actually started this long before we had automated data movement. I mean, basically they would have some manual processes in play, but it was always a transaction, deposit, and they follow the money, which is pretty important. So commit, rollback, and save point are not supported. Well, they are supported because we're using developer. I need to take that out. Those particular items, we don't have you run them because they're, well, you can, and I'll show you how to do that. Here in this lesson, so transactions are a fundamental concept of all database systems. Transactions, all the database systems have them, allow users to make changes to data and then decide whether to save or discard the work. This is one type of transaction. Database transactions bundle multiple steps into one logical unit of work. Transaction consists of one of the following: a DML statement, which constitutes some type of change, insert, update, delete; a DDL statement, create, alter, drop, rename; or a DCL statement, which is grant to revoke. And I didn't really mention this, but we went through that whole section on grant and revoke. That is referred to as your DCL. You'll hear that. You have DML, which essentially, well, think of DML as modifying data. DDL as how do I remember this? DDL is usually object-oriented, meaning you're changing tables, and DCL is the privileges. So those three particular components are to break down your SQL. All right, back to our analogy with the bank. So the bank contains balances for various customer accounts, as well as total deposits balances for other branches. So you've all been a part of a big banking system, even though you don't think so. Suppose the customer wants to withdraw and transfer money from his or her account, and deposit into another customer's account at a different branch. Yes, you can do that. So there are several separate steps involved to accomplish this pretty simple operation. So both bank branches want to be assured that either all steps in the transaction happen or none of them happen. And yes, the ATMs actually run by this system. Either everything occurs correctly, or they basically remove all the processes. So that's the whole idea of what TCL is all about. So grouping the withdrawal and deposit steps into one transaction. So it's multiple steps in modifying or impacting data. So in our database scenario, if we want to talk about the verbiage, we use the commit and rollback. And you can commit is just like you committed to that transaction. Now it's actually running. Rollback is like, well, you can just remove or discard the changes and go back to where it was to start over. So you do have that capability or those capabilities. Now there's also something called save point, which is a part of our little analogy in controlling the transaction. If for some reason you want to stop and save, call it a save point or a marker of the transaction, now you can either go back to the beginning or go back to your save point. So it'll chunk the transaction into smaller pieces, way back into procedural days. And you can roll back to the beginning or roll back to the save point. And this is essentially how some of the programming languages are built on this whole idea of transactional transactions. All right, so in this example here, we're updating something in a table. We're actually going to create a save point. So update department set manager ID equal to 101, or department ID is equal to 60, and then we're putting a save point. So what this will do now, it has a save point where we're saving this as a kind of a place where we can focus on. And as you see, the results is it updates that role and then it creates a save point. You're like, well, you probably want to create a save point before you update. Well, you could do that as well. So after the update statement, let's say, oh, someone came in and said, no, that's the wrong department. So you can do a rollback to save point 1. And what that will do, that will roll it back to before the update. All right. And it seems a little awkward. We created the save point after the update, but basically the system will recognize that you're creating a save point on that DML statement to ensure that if we wanted to do a rollback, we can roll back to that. And then we just run remember, you don't necessarily have to run a commit. Whenever you run a statement in the Oracle developer, the commit is automatic, which means that it's committing it to a complete transaction. That's what that stands for. All right. So you're thinking, wait, that kind of didn't make sense to me. So now I need to illustrate, when does the transaction start and end? So the transaction begins with that insert update or that DML statement. The transaction ends when you have that default commit or a rollback. In a DDL, the same thing. When you run that statement, that's the start of the transaction. When you create a save point, you're creating a save point to before that transaction or that statement. I don't want to mix the two. Is ran or run, excuse me. And that's generally probably the biggest and the most important usage of using this whole idea of transaction. So if you put several transactions, so after one transaction ends, the next executable SQL statement automatically starts the next transaction. So a DDL or DCL is automatically committed. As I said before, commit is a default in this developer, so you don't actually have to type out commit. So we do talk about data consistency and data validity and all that. So imagine spending several hours making changes to the employee's data, only to find out that someone else was entering information. Once again, this would rarely happen in a real life scenario, because you as a database administrator you make sure that only you or maybe your backup can make changes to any of the data. So there's no simultaneous. All of my DBA years, there's never anyone simultaneously making changes. They may be selecting information, but not making changes, which can create a problem as well, which is why we use the whole idea of read consistency or read only, etc. Read consistency is this one you will need to think about, because this guarantees guarantees a consistent view of the data of all users at all times. But you could have several users accessing the data simultaneously, although once again, with the resources now and the timing of this, unless there's wholesale changes being made on the data, it is going to be consistent, which is, I guess that's another reason why I would not allow any DML or any DML other than select. There's really no reason on as far as changes in your data that someone needs to update or insert. That's usually the DBA doing that, or a process controlled by the DBA. So I know this is, you need to know this information and these aspects, especially in Oracle. There's several ways you can roll back, you can do all kinds of things, but generally to be comfortable with, even with read consistency, you should know that, yeah, you can run several selects, create snapshots, and that's what the read consistency does. Essentially, it'll create a snapshot of the real life data at that particular instant in time. And yes, you need to know this. I mean, this talks about two different users simultaneously, but I would, for reason, and I will make this suggestion, this is my real life suggestion. If you become a database administrator, yeah, I mean, basically, when you're granting privileges, select only or read only, period. And if I spent 5 years and they would submit a request to me to update data, or it would go through a process where it would hold until I approve it, that way you're controlling the consistency of the data. Although with Oracle, you can add this read consistency and that will eliminate any changes. But once again, I would suggest take care of that on the front end, because you're responsible for the validity of the data throughout. And yes, you have the capabilities of running these particular aspects, but yeah, and that would be my blanket recommendation. I mean, everyone is wanting to view the data. You should be the one that controls the data, period. And this is speaking to the whole transactional process and how it works, to know whenever the data is changing, you should be aware. I used to have all types of notifications, even if someone tried to access a certain part of the data, you can differentiate it that way, that they're not supposed to view. So that would be the only thing that I would control as far as the validity of the data. But in this topic, it does speak to these particular types of transactional services, the commit, rollback, save point. And so these are referred to as a TCL part of SQL. And it controls essentially what happens when, and if you needed to do a complete rewrite or rollback of the data, or someone made mistakes, and yeah, even when I was way back in the old days, it was always, configure the validity of data first and then provide access accordingly. And here's a kind of a pictorial representation where you can create save points and you can roll back to a save point. Even if someone deletes something, remember it's not completely deleted, etc. This just gives you the option as far as, and this is giving you a time. If you run these particular transactions, delete, insert, update, which no, I would never give those privileges to anyone but myself. Now, if I made a lot of mistakes, which I'll say, no, I didn't allow myself to make mistakes. You can't do that with data. But this is giving you the representation of how you can recover from that using this TCL save point, rollback, commit scenario. All right, there's well, you're always running implicit transaction processing. In the developer, you can put 5 or 6 queries in your query builder and run them all at the same time. You know that, right? But it will run them sequentially. what I would suggest, if you do that, put in a save point or something if you want to, because it'll run everything that's in that's defined clearly in that developer. Just, you know, in our scenario, it's not a big deal. There's auto commit and all that, but we can always refer back to, and you have the skills now. If you wanted to change any of the data in your schema, or you can even, I'm going to change that starter class because we don't really need that anymore. But because it adds everything all at once that you probably don't even and some of it won't even run anymore. But anyway, my point is that you always have a way to even without using that, to roll back to the original data. Our data is very rudimentary, but it is representative, very much representative of a particular company setup. I'll just say that. So the whole idea of what you're learning here, this structure, the schema is really pretty common. Employees, departments, and you get into parts and sales and accounting, all these things. The whole idea that they're connected, and you do have the capabilities in an Oracle database to recover. And we're not going to get into that. You will get into that more in the PL SQL, but know one thing: if there's any type of system failure, the Oracle has an automatic way. It has a utility that will recover all the data. There's an integrity mechanism that Oracle built in many years ago that's still running today, where you can't destroy the data unless you allow it. Well, unless you blow up the server or whatever, but the data persists, and even Oracle has an integrity mechanism built in. Locking data, basically Oracle has this is another internal processes where if you have 1,000 people selecting the same table at the same time, it'll actually lock each instance so that everyone gets what we call clean data. As long as the data is not changing, everyone will get the same representation of the data. And that's actually that's true in most database systems. And this is so rapid now, it's microseconds. It locks it and distributes because the speed. I do remember where we would have to wait a few seconds, because someone else is doing something on that table, but it's not the case anymore. So this describes how Oracle locks the data, and in some of these Oracle systems, some of the DBAs, they've gone as far as to create things that are views. You know what a view is? They'll push the view out to the user. They never really even see the table. And there's a thing called temp tables that we hadn't talked about, but it's like a view. There's so many ways to lock the data that's in the actual primary table that you're not affecting at all. So the way this process of locking the data to ensure data integrity, yes, that's important. And you need to know that you have that automatic system in place. And there you go. So as far as transaction, know that commit your basic terms here: commit, save point, and rollback. You do have read consistency, and TCL, or transaction control language, is that basic. And at our level, at this level, it's just know that, you do have a way to save your data from whatever being impacted by whatever process is being run. So that's kind of the whole idea of a transaction scenario in Oracle. All right, so what's left? So, well, we finally got through all that. What do we have to do now? So I'm going to go over, we have this week, I'll go over that, and I'll talk briefly about the final project, final exam. Don't panic, I'm going to detail that next week and tell you all that's required. Our last 2 weeks will just be spent on the final project and final exam. And then you can go, phew, all done. All right. So let me bring over our, go through, I will post the recording and the lecture in our placeholder here. We do have, so I'm gonna go over this first, and then I'll speak to what we have next. So practice queries on these particular topics, 17 and 18. Yep, all very useful. Read through these, scan through them. They are very helpful. And then your practices, you have 17.1, practice and solution, 17.2, 17.3. And hopefully you're going through those. I will suggest again, if you're not going through these, the final will be very difficult. I'll just say that. Yeah, I pull every single question is from either the practice or the assignments. No big mystery. And I think you saw that in the midterm. This video is actually pretty good talking about TCL. It's the only one that I provided because he does a pretty good job of illustrating what commit rollback, what is that? So you can review it there. And then I expand a little bit more on the TCL and more TCL queries. I remember the privileges. I think I don't remember what I illustrated here. I think I just recreated this one. But you'll have exercises to change privileges and all that. This is the transaction. Remember, you can't run those, but I do want you to build those queries. Yeah, let's go back here. Let's do this. Oh, just have it down a little bit. All right. So yeah, here's a bunch of transaction. Yeah, please read through these. That's very useful. That's what's spinning here. And then for module 18, you have your practice and your solution. And then as far as what you're required for, you have a module 17 assignment. There's a doc, and there's some additional resources straight from Oracle, right out of their news site. And this is just like a regular assignment. Pretty straightforward. Try to solve it. 4 questions. So please go through those. And then, yes, it's a combined quiz. For module 17 and 18, controlling access control and all that, privileges, regular expressions, and then transactions. And that's it as far as the assignments. Woo-hoo. You're happy, right? All right. So what's next? You have this final project, and please don't worry about it. It's just you're going to build. You're not going to build a complete database. You're going to build tables that will look like a database. So and we're going to walk through most of it next week. So you know exactly what you need to do. And I will give you a head start. So make sure you're here next week. And there's all these resources, and I talk about there's a rubric in here, and it's not a big deal. The project is not a big deal, but you just have to do it. And then you have a final. Yes. No final. It's modules 9 through 16. 17 and 18 are really not on there because you can't really do those. So there you go, 9 through 16. And the way it's going to run, yes, it's respond to lockdown browser again. So download that and I will also highlight that on Monday the 5th. It's going to open Tuesday, and it'll close our last day of class on Friday the 9th. So the 5th is it's our final exam review day, but it's our party day. So we're gonna have a virtual party. We're gonna have music and singing and dancing. Okay, not all that, but we're gonna talk about the final. It's 50 questions, 2 points each. You get 2 hours to do it. Once again, you open it, you finish it, you say, yay, you're satisfied, you're done with the class. But so what my plan is then is, so you have the assignments this week, 17 and 18. And then basically it's 2 weeks of no lecture. Just we'll meet and talk. Next week, I'll talk about the final project. I'll even walk through what I'm expecting. And then 5th, our last lecture, our party lecture. Well, after we talk about the final, then we'll have the party, right? The virtual party. So, and that's it. That is the class. So, any lingering questions? You've all made it. You all feel okay? Phew. Was it a lot of hard work for you? Yeah. Some people and Vera says, piece of cake. But yes, we have felt reasonable. Thanks, Vera. As I said, I put in a lot of effort. I'm not patting myself on the back, but I'm trying to update, and you guys are kind of guinea pigs, sort of, because I'm trying to update this to make it more appropriate. And I'm pulling in additional information from the Oracle Academy, but I did change a lot in this version of it. This is the 4th time that it's the 6th time I've taught this class. And yes, I followed all the guidelines, but my director says, oh, you did okay. So I'll let you teach it again in the fall. Yay. But I'm going to upgrade it even more over the summer. So I do appreciate if you have any feedback, get a chance to, I think you have in the class survey, make sure you fill it out frankly, or, tell me what you like, what you didn't like. But it's been an experience. I appreciate your hard work, and I'm glad that you all made it through. Well, almost. I mean, you got a couple things to do, small things. You made it through last week. I think that was the hardest. Well, maybe not. I don't think it was, but you made it through, so you can be happy about your successes thus far. And I think you all learned something, right? And believe it or not, SQL, I can't overstate how important this particular part of if you're interested in data, which you have to be, it's part of everything. You should know SQL. I can't believe it's so important now, as important now as it was when I started way back in the 80s. So yeah. All right. So that's all I have for this evening. Thank you all. Once again, next week, it's project week. I'm going to highlight exactly what you need to do. That's all it's due. Well, actually, that's not due until actually the 9th. So you can. I'm hesitant to say this, but yes, you can procrastinate a little bit. You have nothing due next week. Phew. But and then you have the final week. Ooh. So, and then you're done. So get through this one assignment this week, and then take a breather and just take a deep breath and prepare for summer. Unless you're going to summer classes. Who's doing summer classes? That's just crazy. All right. Thank you all. Have a good evening. I will see you all next week. Okay.
Thank you.
Thank you.
Thank you. Take care.
Thank you.